Hello friends, welcome to EPG Pathshala in the subject of Information Technology for the paper Mobile Computing. This is the fourth lecture in this series and our today's topic is Signal Propagation Effects. In the previous modules, we have learned that for wireless communications, we need electromagnetic waves which are characterized by the properties like amplitude, frequency, wavelength and phase. We have also seen that according to these attributes, namely frequency and wavelength, the electromagnetic waves are divided into different bands and it comprises the electromagnetic spectrum. We have also seen in the previous module that not all the part of the spectrum is utilized for communication, only the radio waves, microwaves, infrared waves and the visible spectrum is appropriate for communication. Then in the previous module we learned that finally this wave is used to carry the information from transmitter to receiver and the physical representation of this data is known as signal. The signal can be analog or digital. An analog signal contains the information in a continuous manner, whereas the digital signal contains discrete information generally in the form of zeros and ones. So, up to the previous modules we have learnt about the concept of electromagnetic waves and its physical representation, the signal. Now, in this module we will learn that when the signal is going from transmitter to receiver, what all happens during the way. That is, see, whenever you are using wired communication, everything is concealed in the wire itself. So, no environmental objects, no air, no atmosphere it encounters with. But when we talk about wireless communication, the signal is travelling from transmitter to receiver in air or in open. So, everything will come into its way. Air will be there, atmosphere will be there, environmental objects like buildings, vehicles, trees, everything would be there. So, in this lecture we will learn that what are the different ways in which the signal can travel from the transmitter to receiver and what all happens when it encounters with the environmental objects. What do or what effects do these objects pose on the signal? Does they degrade the quality of the signal or does they help in the communication? So, this all we will learn in this module. So, to start with, the topics which we will be covering in this module are, we will learn about the signal, just we will have a recap of the definition of the signal. We will see that what are the different modes in which the signal propagates. It depends on the frequency or the wavelength of the signal. So, we learn about the three modes, namely the ground wave propagation, the sky wave propagation and the space wave propagation. Then we will see that what are the phenomena which affects the signal when it goes from the transmitter to receiver. As I just said that there will be environmental objects and these environmental objects namely pose four type of effects on the signal. These are the physical phenomena you might have also learnt in your lower classes, and the phenomena are reflection, refraction, diffraction and scattering. We will see that what type of objects pose what type of phenomena and what happens to the signal then. Then we will learn that what are the different effects that occurs due to these phenomena or due to these physical effects on the signal. We will learn about multipath propagation, delay spread, intersymbol interference, and we will see that in how or what happens to the signal when it goes through a multipath, or what is delay spread and what it does with the quality of the signal, what is intersymbol interference and so on. So, let us start with our module. Just have a recap of the definition of the signal which is discussed in the previous module. What is a signal? It is a physical representation of data by the transmission of which communication takes place. So, we want to transmit some data and how that is transmitted. So, via the electromagnetic waves, and we put the data on the electromagnetic waves, it is a signal. So, anything can be put or anything can be represented using the signal. My voice can be represented, images, letters, numbers, anything can be represented or carried by the signals. We have also learnt in the previous module that the signal can be analog or digital, and analog means continuous, digital means representing the discrete values. Now, let us see that what are the different modes in which. Now, let us see that what are the factors which affect the strength and path of the EM waves or the signal as it moves from transmitter to receiver. The first thing is distance, second is frequency or wavelength of the wave, third is Earth's atmosphere, and finally the environmental objects. So, in this module we will see that what are the effects of these factors on the quality of the signal. So, first let us see that what are the three different modes in which the signal propagates. As I just said that the three modes are ground waves, sky waves and space waves. Let us start with ground waves. Ground wave propagation is also known as surface wave. Why it is known as surface wave? Because the waves or the signal follow the curvature of the earth. Waves with low frequencies follow the earth's surface. Now, you have just read that the frequency should be less than 2 megahertz, very low frequency. So, what happens is that as the frequency is low, the signal will travel down. It will follow the curvature of the earth. Now, why it follow the curvature of the earth? The reason we will just see. Now, as a result, we know that the earth is spherical in nature. So, if I use the line of sight, I would not be able to transmit over the horizon. So, these types of waves follow the curvature of the earth because they bend along the earth due to the phenomena we will just see. So, due to this bending, they follow along the curvature of the earth and hence they can also follow the horizon, right. The antennas for this type of propagation is bigger in size and located near the ground. Now, we know that antenna size is proportional to the wavelength. Now, I am saying that the frequency of the ground wave is less, and we saw in the last lecture that frequency is inversely proportional to wavelength, which means that if the frequency is less, the wavelength would be more, right. So, if the wavelength is more, the antenna size will also be bigger because the antenna size is directly proportional to the wavelength, right. And these type of antennas, now since the wave is following the ground, these are more nearer to the ground as compared to other propagation like space waves in which the antennas are little above the ground. These waves sometimes they travel so below the surface of the earth that they can even penetrate the ground and hence make them suitable for submarine communication. They are also used in some of the radios, typical AM radio. Just look at the animation, what I just explained, that there is a transmitter and the receiver and the wave is following the curvature of the earth. Now, let us understand that why it follows the curvature of the earth or why it is travelling so nearer to the ground. Electromagnetic waves induces a current in earth's surface due to which it gets slowed down or attenuated due to the absorption near the earth. What will happen that when they will be attenuated, the waves will be tilted downwards and hence follow the earth's curvature. You can see in the diagram also that as the waves are going, the tilt towards the earth is being increasing and increasing, right. And you can also see that these waves nowhere interact with the atmosphere, they are very much close to the earth's surface. The second reason is that, as I just told, in this range the electromagnetic waves are scattered by the atmospheric layers in such a way that they do not penetrate the upper atmosphere. The third phenomena which cause them to bend is diffraction. Diffraction is a physical phenomena due to which the waves bend about the obstacle. So, due to the diffraction about the surface of the earth, the waves bend, and this is more the frequency, more is the attenuation or bending. So, finally, what will happen is that the distance travelled would be short. So, you can just see here also that more and more you are going away, the signal is getting attenuated and finally it will diminish. So, the distance travelled by these type of waves is less. Now, what are the factors which affect the distance travelled by ground waves? First is of course the power of the transmitter. More the power of the transmitter, more far the waves will travel. The second is frequency of the transmitter. Now, we know that as we move, we also learnt in the previous module that as we move towards the higher frequency, the attenuation is more, the obstruction is more. So, here also as the frequency will increase, suppose we are at 2 megahertz and slowly we move towards 15 megahertz. So, the attenuation towards 15 megahertz would be more. Condition of Earth's surface, the conductivity of the ground, the terrain roughness, the dielectric constant all affects the signal attenuation. So, ground and also it affects the penetration. So, the ground penetration also varies as per the frequency. Lower the frequency, more is the penetration. And the fourth factor which affect the distance travelled by ground waves are the environmental objects. So, if there are obstructs like buildings, hills, etc., they will attenuate the signal due to reflection, diffraction, and hence the distance travelled will be less. So, they will more attenuate before they reach the receiver. So, this is about ground waves. So, what to do? As I just said that the ground waves travel only to a shorter distance. So, what to do to travel to the longer distance? It is not that I can just confine my transmission only to a certain area of the earth because it is spherical and so I cannot go across the hemisphere. There is a very interesting feature of the atmosphere which allows it to do so, and fortunately the radio waves also comply with this feature, and the combination of these two things is so interesting that it is helping you to send the transmission across the hemispheres of the earth. Now, what is this particular feature of the atmosphere? You must have heard of the layer called ionosphere when you were in your lower classes. The atmosphere is made up of many layers and one of the layer is ionosphere. What is that layer and how it helps in the transmission to longer distances? Let us just see. Now, what happens is that there is an atmosphere, you have the sun above the atmosphere, the sun's rays reaches the atmosphere, these are cosmic rays. Now, what they do with the atoms which are existing in the atmosphere? They ionize these atoms. Now, so what will happen is that as the sun's rays reach layer to layer, the ionization will be there. Now, let us see that what part of the atmosphere I can use here. Now, one thing you have to learn is that as you come down, the layers of the atmosphere becomes more and more dense. Okay? Dense means there are more atoms in it. Okay? So, let us talk about the upper layer of the atmosphere. When the sun's rays will reach there, the atoms in that layer will get ionized. Fine, but that layer is rarer than the lower layers. So, there will be atoms, but very less atoms would be ionized. Now, the sun's rays cross that layer and it reaches the middle layer. The middle layer is denser than the rarer layer. So, what will happen is that those atoms would also be ionized, but here since the density is more atoms would be there and they would be ionized. Now, the sun's rays reaches the next lower layer, again the density would be more. Now, what do you expect? As I just said that you must be saying that since the density is more more atoms would be there and hence more atoms would be ionized. So, the ionized particle would be more in this layer, but it is not so. In fact, the atoms which gets ionized in the lower layer are less. Why? Because the sun rays is not reaching here itself. Okay. The sun's rays or the cosmic rays, as they are penetrating from the upper layers, as they reach the lower layers, their penetration decreases. So, here also the number of atoms produced is less. So, what are we left with? As I just said that the upper layer is rarer, so less atoms would be ionized. The lower layer is denser, but the sun's rays do not reach here, again the less atoms would be ionized. So, I have to agree upon the middle layer which is denser, so the atoms or the ionized atoms are more there. So, that layer is known as ionosphere. Now, what do we do with this ionosphere? Radio waves have got a very interesting property that when these waves reaches the ionosphere, they are reflected back to the ground, and not all waves, waves of a particular frequency, like in the range of 30 to 32 megahertz. When these high frequency waves reaches the ionosphere layers, it gets reflected to the ground station, hence covering large distance. This phenomena is similar to the total internal reflection in optics, and which is also used in optical fiber. So, what happens is that a signal from antenna at a station on the earth strikes the ionosphere, then it is reflected back down the earth, again it goes up, again it comes down. So, the skywave signals bounces back and forth between the ionosphere and earth surface and can travel along a long distance across the globe. So, how are you traveling the long distance? By bouncing up and down from the ionosphere. This type of waves are known as sky waves, and the propagation is known as ionospheric propagation, and the waves in the range of 3 to 32 megahertz undergo this type of behavior. The applications are amateur radio, citizen band radio, that is CB radio, international broadcast, BBC, Voice of America. These all used the transmission in the ionospheric propagation way. Just have a look at the animation. There is a transmitter on the ground and there is a receiver on the ground. I have shown the ionosphere. So, what will happen is that the wave has gone up, it will be reflected from the ionosphere, it will come back again, go back again up to the ionosphere and finally reach the receiver. So, you can see that suppose if I used ground waves, the distance travel, if it would have been only this much. Now, by reflecting it from the ionosphere, my distance of travelling has been increased, and hence I can also send my signal across the two hemispheres of the earth. Now, what affects the distance travelled by the sky waves? Firstly, they depends on the angle of radiation, that is the angle by which the signal is sent from the transmitting antenna. If the angle towards the sky is is less, the distance would be shorter, and if the angle is more, the sky waves will travel longer distance, right. Second is of course the power of the antenna, more the power, more the distance from transmitter to receiver. The third and the most important thing is level of ionization in the ionospheric layer. Now, what do you think would affect the level of ionization? The first factor we just discussed is that the altitude of the layer. Lower the layer from up, that is less is the altitude of that layer, less will be the ionization. Okay. The second factor which I just explained when I explained you the ionospheric reflection was that who produces the ions, or what is the factor which triggers the ionization effect? The rays from the sun. Are the rays from the sun always identical? No. They depend from the time of the day as well as they depend from season to season. So, if we talk about India, the sun's rays in the summer seasons fall directly to the ground and the days are very hot, and similarly in the winter season the intensity of the sun's radiation is less. So, in that season also the level of ionization would be less. Similarly, if I talk about day and night, in night there is no sun, so less ionization would be there and more will be during the day. Now, we have talked about two types of propagation. At a certain frequency or below a certain frequency like 2 megahertz, the waves have got such a big wavelength, they are travelling along the ground. Now, as I shift towards a little higher frequency, I just learned that those high frequency waves have got the capacity to bounce from the atmosphere. That is, they will not be scattered by the atmosphere, but they will reach the ionosphere. Now, if I further increase the frequency, what will happen is that those high frequency waves will penetrate the whole atmosphere and will reach the space, right. So, what can I do with this type of behavior? I can simply use it for satellite communication, because satellite is always placed above the atmosphere. Hence, this type of propagation is also known as space wave propagation. So, at this higher frequency, that is greater than 40 megahertz, the waves crosses the layers of the atmosphere and reaches the space, and from there it can be reflected back to the ground station on the earth, just providing satellite communication. So, you can just see in the animation the high frequency wave crossed the atmosphere and it came back to the ground station via the communication satellite. So, line of sight, these waves are also known as line of sight waves or space waves. The communications follow straight line of sight at frequency higher than 40 megahertz. What do you mean by line of sight? Line of sight means that the receiver and the transmitter should be aligned to each other. As I just said, the signal is not reflected by the ionosphere, it penetrates the ionosphere and escape the layers of atmosphere. The application areas are satellite communication, FM broadcast, two-way radio, AM aircraft communication, aircraft navigation aids, cellular phones, radars, microwave links, cordless phones and all infrared and optical communication. The two factors which affects the distance travelled by space waves are, firstly the line of sight distance, that is the distance between transmitting antenna and receiving antenna at which they can see each other. They are aligned to each other. Whatever the transmitter will send, the receiver will catch it. This is what is meant by line of sight distance, and it is also known as range of communication. And the second factor which affects is the curvature of the earth, because the line of sight waves will always be blocked by the curvature of the earth. So, what do you do to increase the range? So, what you have to do is that if something is blocking your vision, what do? You just stand on your toes and you try to peep. Okay. So, here also the same thing has been done, is that the horizon is coming, or the spherical nature of earth is blocking the line of sight view. So, what should you do? You should place the antennas high above the horizon, as simple as that. So, you just see from above, you will be able to escape from the obstacles which are below. So, simple principle is applied here also, that is, to increase the range, the heights of transmitting and receiving antennas should be increased. So, what should be the ideal height? If I talk about r as the radius of the earth, the height of antenna should be under root of 2r ht, where ht is the height of the transmitting antenna. And if I use this type of antenna, the maximum line of sight distance which I will be able to achieve is under root of 2r the height of the transmitting antenna plus under root of 2r the height of the receiving antenna. Please note that these t's and r's are all in the prefix. So, HT stands for the height of transmitting antenna and HR stands for the height of the receiving antenna. So, we have just seen that what are the different modes in which the signal travels. Now, let us see that what are the phenomena which affects the signal when it travels from transmitter to receiver. So, these are the 4 phenomena: reflection, refraction, diffraction and scattering. What is reflection? You might have also studied in your lower classes. When the propagating signal falls on an object whose size is large as compared to the wavelength of the signal, it gets reflected. So, if I talk about big buildings, big vehicles, water, everything will offer reflection to the propagating signal. Like when I talk about the radio waves, their frequency is less, but the wavelength is very large. Hence, the object which reflects the radio waves would be the bigger objects. But if I talk about microwaves whose frequency is less than the radio waves, even the smaller objects will offer the reflection. For example, if I talk about the GSM signal, the frequency is 900 megahertz and so the wavelength is 33 centimeter. That is, I can obtain the wavelength by dividing the frequency by the speed of the light, 3 to 10 raised to power 8 meters per second. So, what will happen is that this GSM signal will be reflected by the objects of size greater than 10 meter. The reflection also depends on the dielectric properties of objects. So, if the object is a perfect dielectric, some of the energy will be reflected back, some will be transmitted and there will be no absorption of energy. If the object is a perfect conductor, all the energy of the signal will be reflected back, the perfect conductors are the metals, water etc. So, for long distance communication, C is one of the best reflecting surface. So, you can see here that the signal gets reflected and it reaches the receiver. Desert areas are poor reflectors. Then for short range communications, the buildings, that is the surface of the buildings, the flat areas of the buildings, metallic surfaces of the windows, the ceiling, the metallic surfaces of the vehicles, all will offer reflection. The strength of the now what happens when the signal gets reflected? Now, when the signal gets reflected, what will happen is that if you talk about reflection, now it can be something like this. It goes, it will get reflected, it will change its direction and path. So, what is happening? Now, instead of going directly from transmitter to receiver, the signal went to a building, it got reflected from the building and then it is coming back to the receiver. So, you can see that the distance travelled would be more. Now, the distance travelled would be more, attenuation would be there, hence the strength of signal would be more. So, there are in many cases when the strength of the signal degrades due to reflection, because due to reflection the distance travelled is more as compared to line of sight, and we know that as the distance increases the attenuation of the signal also goes on increasing. But this does not mean that reflection always is harmful or it is not helpful or it is an obstruction in the transmission. Sometimes it helps also. How? Like suppose if I want to send the transmission in an area which is out of line of sight, that is the receiver and transmitter are not in line of sight of each other, that is a receiver might be in some of the street. Now, how to reach that street? So, you do not have a direct line of sight here. So, what will happen is that the reflection will help here. The signal from the transmitter will go, it will strike to the wall of the building, it will come back, again some other object will offer the reflection, and in that way it will somehow manage to reach the receiver in the street. So, as I just said that for short range communication, the other objects like the car, the buildings, they offer reflection. So, you can just see that the car is a perfect conductor, metallic body, right. So, firstly the line of sight signal came, then the signal from the car came, and you can just see in the diagram that there is a very less decrease in the strength of the signal when it is reflected from the car. So, almost the whole part of the energy is reflected back, but here you can see that it has been reflected from the ceiling of the building, and so a little part of the signal reaches the receiver. I tell you a very interesting thing. What you have to do is that if suppose you are doing some important work and you do not want to get disturbed by someone, okay. So, you do not want to get disturbed, but at the same time you do not want to put your phone power off, you do not want to put it on mute mode, you do not want to put it on aeroplane mode, because the person who will be calling would simply know that these things had been done. So, what you can do is that you simply take your phone, take a aluminum foil which is available at your home, wrap your phone in the aluminum foil and sit peacefully, because what will happen is that all those signals which are coming to the phone will be reflected back from it. Okay. Similarly, suppose the same thing, if you want to know that whether the rays from your microwave oven is leaking or not, because they are harmful to you, what you have to do is that you just put your phone in a microwave oven. Of course, the oven should be switched off, and then you try to make a call to your phone, right. So, if you can get the call in the microwave oven, that means the signal has got some way to cross the microwave oven, either through some leakage or some penetration. If it is able to reach the mobile phone inside, then there is sure some leakage in the microwave oven, and what you have to do is that you have to simply take that oven and put it in your dustbin, because there is no remedy to it, and the radiations which will cause you harm is much more than the cost of that microwave oven, right. Now, let us talk about another phenomena which is known as diffraction. This type of phenomena is generally caused by those objects which have got sharp edges, like if I talk about the W line environment, the furnitures, the corner of the furnitures, the corner of the walls, everything offers diffraction. If I talk about outdoor objects, the trunk of the tree, the corner of the buildings, the edges of the vehicles will all offer diffraction. Now, what it does is that it bends a particular wave as it passes the edge of the object. As I just said that in ground waves, the waves are getting bending because of the edges of the earth's surface. Now, why it happens so? Because the energy of the waves get redistributed within when it passes near the edge of an opaque object, and it is that phenomena that allows the radio waves to propagate around the corners. So, what will happen is that when it reaches a building and it have to go across the building, so it will be diffracted by the edge of the building, it will be simply get bended, and then it will turn and go to the receiver. Diffraction results in change of direction of the part of the wave energy from the normal line of sight, and because of this it is possible to receive energy around the edges of the obstacles also. Now, lower the frequency or longer the wavelength, the greater is the bending, and it is helpful actually. It can go across the object by just taking a turn, by just bending and then going to the receiver behind it. So, as I just said that lower the frequency, more is the diffraction, therefore, the radio waves are diffracted more than the microwaves. You can just see in this animation the wave from the transmitter, it just got bended around and then it reaches the receiver. So, the corner of the hills have offered this diffraction. Next phenomena is scattering. When the objects in the path of a signal are very small as compared to the wavelength of the wave, what happens is that wave or that signal get broken up into several weaker signal. Okay. So, let us talk about a very interesting phenomena which occurs due to this effect scattering. What did I just said? I said that the objects in the path should be very small as compared to the wavelength. Okay. So, these type of objects will offer scattering, right. Now, let us talk about the visible spectrum. Visible spectrum has the wavelength of the order of nanometer. So, the objects should be of the order of that. So, if I talk about an object like water molecule, right. So, water molecule, precipitation, moisture in the atmosphere, everything will scatter this type of signal. What will happen? So, actually this phenomena you always experience in your day to day life, and it is a very interesting phenomena, and this is the phenomena due to which you see the rainbow. As I just said that why are we able to see the rainbow? How can we see the rainbow in the night also? No. Why? Because there is no light. Now, what has light to do with the rainbow? Actually, light is the light of sun. So, it is the white light. It is made of 7 constituent colors. So, what happens is that when this visible light falls on water droplets actually act as prisma. What is the prisma? Prisma is that object which convert the signal or the wave into its constituent signals. And what are the constituent signals of a white light? The 7 colors: violet, indigo, blue, green, yellow, orange, red. So, whenever the sunlight falls on the water droplets in the clouds, the water droplets in the clouds act as prisma. The sunlight is broken up into 7 constituent colors. We see the rainbow. So, there is a very simple physical phenomena behind this, and the phenomena is known as scattering. Now, we will see that what is the effect of these phenomena. Are these good effects or the bad effect, right? The first effect which we will see is the attenuation. What do you mean by attenuation? Attenuation is the decrease in strength of the signal. This decrease can be due to many reasons. It can be due to distance, that is when the signal travels away from the transmitter, as it goes away the strength of the signal decreases. Okay. Many other objects also which are on the way may offer attenuation. So, the formula for the attenuation is 10 log the ratio of transmitting power and the receiving power. So, you whatever you have transmitted and whatever you have received, you take the ratio of that and then you take the 10 log of that, you will get the attenuation. For example, if the signal was transmitted at 10 milliwatt amplitude and then it encounters a wall which is a dielectric. So, it will absorb some of the signal and hence the power will be reduced to 5 milliwatt. So, almost half of the signal strength has been gone. So, what will be the attenuation? The attenuation will be 10 divided by 5, 10 log 2 which is equal to 0.3 or equal to 3 decibels. So, this signal has undergone 3 decibels attenuation. If I talk about the ideal isotropic antenna, and if I do not talk about the objects in between, the free space loss, that is when there are no objects in between, the Pt by Pr, that is the ratio of transmitted power to the received power, is given by 4 pi d whole square divided by lambda square. And if I convert, where lambda is a wavelength, if I convert this into frequency, what will you get? 4 pi f d whole square divided by c square. Now, 4 pi and c square both are constant. So, what are the variables here? F and d. So, I can say that the received power is inversely proportional to frequency, and the received power is also inversely proportional to the square of the distance. Let us just look at the this free space laws. Free space propagation is when the transmitter and receiver are in line of sight with each other. There are no objects in between. The signal simply goes from the transmitter and it reaches the receiver. So, what should happen? That there should be no signal loss also. There are no objects, it is vacuum, it is free space, but still there is reduce in the strength of the signal, and which is known as free space loss. Why it happens? It happens because the distance has increased, and I just said that the received power is inversely proportional to square of distance. So, as you move away, and this is for the isotropic antenna. So, why it happens? So, because in the isotropic antenna the signal radiates from the transmitter and it spreads along the area of the sphere. So, if I go away from the transmitter, actually the distance increases as the square. So, the strength of the signal reduces as per the square of the distance. For example, if the transmitter sends a signal of strength 16 watt per centimeter square at the distance of 100 meter, right. So, what will happen to the strength of the signal at the distance of 400 meter? So, what has happened is the distance has increased 4 times. So, as the inverse square law, the strength should be decreased 16 times, because the strength is inversely proportional to square of distance. So, what you will get, the resultant power or the resultant signal is just 1 milliwatt per centimeter square. You can just see in the diagram that as you go away from the transmitter to the receiver, even though there is a free space, even though there are no obstacles, there is decay of the signal as the distance. Now, the another factor is blocking or shadowing. This is the ultimate form of attenuation, right. When the whole of the signal which falls on the objects get attenuated, it is blocked, right. So, very big objects might offer blocking. The effect is frequency dependent. Of course, greater the frequency, more it behaves like light and it gets obstructed even by small obstacles. Lower the frequency, the penetration is more. Therefore, the long waves can even penetrate through the oceans and used for submarine communication, while the small waves like the infrared, the visible or the microwaves can even be blocked by a tree. Now, tree is a very big object actually. They can be blocked by the atmosphere also, they can be blocked by the oxygen, the rain, fog, everything. Like if I talk about a signal of frequency 22 gigahertz, even the water vapor and the oxygen in the atmosphere will attenuate the signal. Oxygen actually absorbs the signal in the range of 30 megahertz to 30 gigahertz to 60 gigahertz frequency. Similarly, rain and fog also attenuates the signal at high frequency. Therefore, in the areas where there is more precipitation, low frequency bands are used. Similarly, flat surfaces with the dimensions larger than the wavelength offer reflection, whereas rough surface contribute to scattering. The reflection, diffraction and scattering, when they fall on the objects, they also change the path. Now, let us talk that suppose there is a signal, it got reflected from an object, then it reached the receiver. Another signal, it followed the same line of sight. Another signal, it got scattered, it got broken up into several signals, then it reached the receiver. Another part of the signal got diffracted from some object and then it reached the receiver. So, what is happening is that instead of taking a single path, the signal is taking many paths, and those paths or those components which are taking different paths are known as multi-path component. Now, they will arrive at the receiver at different time. with different amplitude with different phase, and this type of phenomena is known as multipath propagation. So, you can see that from the transmitter the receiver reached the tree, it got scattered from the foliage and then it reached the receiver. Similarly, one signal got reached by direct line of sight, the other got diffracted by the edge of the building and then it reached there, and the another got reflected by the metal surface of the car and then it reached there. All these are known as multipath components. Now, the first thing is that the different components which are getting reflected or diffracted or scattered will follow the different path. At the same time, they will also travel different distances. Some distance might be long, some might be short. Now, the speed of the signal is same, that is the speed of light. So, there is no change. So, what will happen is that due to the increased travelling distance, each signal will arrive at the receiver at different times. Maybe the distance which the signal which covered the smallest distance, it will reach first, then the signal with lesser time will reach, and then the signal which took the maximum time will reach. So, actually the signals are arriving at different time intervals, and this effect is known as delay spread. Let us see what is delay spread. Due to finite speed, multipath components travelling along different paths with different lengths arrive at receiver at different times. At the same time, each component may also suffer attenuation. Some may not be detected at all and rejected as noise. This effect is known as delay spread. This effect is more observed in cities. Like in cities, the delay spread is about 13 to 12 microsecond, and the technologies have adapted a different mechanism to handle the delay spread. So, GSM can tolerate up to 16 microsecond delay spread. So, you can see that the signal is going from direct line of sight, then it is getting another reflected signal, this is another component, and the third component is reflected from the vehicle. Now, you can see that the distance travelled by this signal is more than this signal, than this signal. So, what is expected that this signal should reach first and also with more power. So, you can see here that this signal is reaching first with more power, then this signal denoted in purple, and then this signal denoted in green. So, actually all this signal should have arrived the receiver simultaneously, but they are arriving at different times, and this effect is known as delay spread. Also, what will happen is that now when these multipath components are reaching at the receiver, they will interfere with each other. Okay, as I said that they are overlapping in time, they are overlapping in amplitude, they are coming there in different phase. So, what will happen is that when they reach the receiver, sometimes they may reach in phase. What do you mean by in phase? When they say phase difference between the two signals or the two waves is 0 degree. We have discussed about the phase shift in the previous lecture. Okay. So, what happens is that this type of interference is known as constructive interference. The resultant power of the resultant signal will be the addition of the powers of two individual signals. The effect is known as constructive interference. Okay. So, you can see in the diagram, this is constructive interference. So, these are the two signals and they are arriving the receiver in phase, that is the phase difference is 0 degree. So, this is first signal overlapped with the second signal, and what did I get? The resultant is a stronger signal. Okay. Then the destructive interference, when the two signals are arriving out of phase with each other. What do you mean by out of phase? When the phase difference between them is 180 degree. This phenomena is known as destructive interference. So, one signal came here, the other signal came with 180-degree phase difference. The two got interfered at the receiver at 180-degree, that is out of phase, and the result is destructive interference. Their powers got cancelled out and you almost got nothing at the receiver. Okay. Actually, the power received is the difference of powers or the amplitudes of the two individual components, but if the amplitudes of the two signals are equal to each other, they will cancel out each other when they interfere destructively. The third phenomena is intersymbol interference, which occurs when data is being sent, and this also is a effect due to multipath component and occurs due to delay. Now, just look at the diagram, you will understand the meaning. 4 symbols have been sent, S1, S2, S3, S4. Okay. This is the first path. By the second path, the signal was little bit delayed. Okay. So, the symbols sent would be when S2 along the first path was sent, S1 along the second path was sent. Now, this is the delay. Okay. So, this is the second path. The third path, again the delay is more. So, when the third symbol of the first path or the second symbol on the second path has been sent, the first symbol on the third path is being sent. Okay. So, you can see that this is happening due to delay. The delay along the first path is 0 almost. Delay along the second path is equal to the time which is required to send one symbol, and the delay along the third path is the time required to send 2 signals. Okay. So, what is happening at the receiver is that at the receiver you are getting the interference or the blending of these symbols, and the effect is known as intersymbol interference. So, each multipath component arrive the receiver as a sequence of pulses with different time, amplitude and phase called intersymbol interference. So, we have just seen that what are the effects of the phenomena reflection, diffraction, diffraction and scattering, and the that is the multipath components, the delay spread, destructive interference and intersymbol interference. Now, what is the solution to it? These are problems, but we get a very good quality of service. So, there must be some solutions which have been implemented to reduce or to minimize the effects of multipath components. Now, that adoption is the introduction of 2 technologies, MIMO and OFDM. MIMO stands for multiple input, multiple output, and OFDM stands for orthogonal frequency division multiplexing. So, in orthogonal frequency division multiplexing, the signals are orthogonal to each other. So, they will not interfere at all. So, no constructive or destructive interference. So, this is the technology which is used in 82.11n, Wi-Fi, LTE Advanced, WiMAX and many more technologies. MIMO is a technology which actually takes out the good from the worst. What does it mean? It is a technology which actually takes the advantage of multipath propagation. What it does is that to handle the or to minimize the effect of multipath propagation, it uses multiple antennas. And what will happen that these multiple antennas will handle multiple data stream on the same channel to increase its capacity. You can just see the diagram. The first is the direct line of sight signal. This is three-way MIMO, 3 inputs, 3 outputs. Now, second signal will go again the second input channel and it will reach here, and the third is going through the third input channel and then it is coming here. Okay. So, actually no interference. Now, all the 3 the components at the receiver are handling the 3 multipath components. Okay. And the last topic in today's module are the rake receiver. These also are a solution to the multipath components, and these are used in WCDMA where the codes have been used to spread the signal. So, what is done in the rake receiver is that they receive the signals from the multiple paths, that is the multipath components, and then they combine them suitably with appropriate delays and recover the transmitting signal. So, at the receiver first the signal is demodulated, and after that the chip stream that is in CDMA we have learned that the chipping sequence is sent along with the data. It is fed to different correlators instead of one correlator, and each has got some amount of delay, and then the signals are combined appropriately based on the estimated weighting factors using the channels. So, to summarize this module, in this module we learnt about the signal propagation effects. We have learnt about the three modes of propagation of the signal when it travels from transmitter to receiver, that is the ground wave propagation, which is used by the signals of low frequency, in which the signal travels along the ground. Then we learnt about the skywave propagation, in which the signal gets reflected from the ionosphere layer of the atmosphere, and by bouncing up and down it reaches the ground station. The third layer, when the frequency is much more high, the signal is able to penetrate the layers of the atmosphere and it reaches the ground station, as is used in satellite communication. Then we learnt about the phenomena reflection, diffraction and scattering, and the objects which offer these types of phenomena. We have learned that what happens when reflection takes place, the signal changes its path, it might be absorbed by the object, it reaches the receiver following a different path with different intensity. Diffraction causes the waves to bend around the obstacle and reach the other waves. The scattering breaks the signal into weaker components. More the frequency of the wave, smaller objects are required to scatter the signal. Now, when the signal, after undergoing these phenomena, reaches the receiver, instead of following the direct line of sight, they take different paths, they get attenuated, and these paths are known as multipath components. Okay. And each component arrives with different amplitude, with different phase at different times, due to which the phenomena delay spread and intersymbol interference occurs. To minimize the effect of a multipath propagation, MIMO, that is multiple input multiple output, OFDM and rake receiver are being used. So, this is all for today's module. Have a nice day.